Hey everyone, welcome to topic number 23, solving what we so-called system of equations. So we're going to take a break from factoring. We will get back to it. So for the next few topics, we're going to talk about system of equations. So system of linear equations or linear programming is basically a set of two or more linear equations with two or more variables. Okay. So basically, here, for example, this example right here. The entire thing is called a system of linear equation. It consists of two or more variables. Therefore, we will need two or more equations in order to solve multiple variables. So in a way, we are learning how to not just solving one variable, we are learning how to solve multiple variables at a time. All right. So the first way of solving system equation is by graphing. All right. So if an ordered pair is a solution to the entire system, okay, the example I just showed you, we say that this ordered pair is the point of intersections of the two lines. So by graphing simply means we're going to graph two linear equations. We're going to graph two linear equations. If the two linear equations intersect, then what that means is both lines carries exactly the same point. Therefore, that point must be the solution to the system. Okay. So when we see, if two lines carry the same exact point, then the two lines must intersect at that exact same point. Therefore, that point got to be the solution to your entire system. All right. So in a minute, we're going to actually learn how to look for that point intersection. All right. There are three types of solutions. That means there are what two lines can do. Two lines I know can intersect at one point. That means you got one solution. Therefore, the system is consistent and the equations are independent to each other. All right. Consist. You can think of a consistent means I have a solution. Parallel lines, no solutions. If two lines are parallel, that means they never intersect. They never intersect because they do not carry the same point. We also know parallel lines from the previous we also know parallel lines from the previous topic means the two lines have the same slope. Okay, but so for here we know that parallel lines do not intersect. Therefore, you have no solutions. So if you don't have a solution, then the system is inconsistent. However, the equations are still independent from each other. Okay, same line. If two equations are exactly the same and you graph them, you will end up graphing two lines on top of one another. So therefore it becomes the same line. So technically you are graphing two lines. If you graph two lines and you end up drawing them one on top of one another, technically you are intersecting infinite number of times. So if it's the same line, you will have infinite number of solutions since the lines are intersecting everywhere. So you do have an answer, your answer just infinite. So that's why the system is inconsistent. But the equations are dependent because since it's the same line, so that means they depends on each other. If one changes, the other one has to also change to actually stays as the same line. All right. So three types of solutions. One solution, no solution, or infinite number of solutions. So let's take a look. All right. So here I got a system of linear equations. Okay. So that means I'm going to end up drawing two lines. Solve for y in the first equation. So I'm going to say this is the first one, this is the second one, okay? I'm going to solve for y for the first equation and state the slope and the y-intercept because I'm going to use the slope and the y-intercept to help me graph. So x plus 3y equals negative 10, solving for y. So the variable term is positive. I'm going to move the x over. So that should give me 3y equal to negative x minus 10. Divide every term by 3. So my y must be negative 1 over 3x minus 10 over 3. Oh, maybe that's not a very good example because it's hard to graph 10 over 3. Let's make that into a 12. How about that? Let's make that into a 12. So divide everything by 3, that will be minus 4. How about that? Change that negative 10 to negative 12. All right, my slope M is -1/3. My y-intercept 0, comma, -4. Okay, same thing as what we done in the previous topics before. All right, so I'm gonna go ahead and graph it. So I'm gonna go ahead and plot my y-intercept. I'm gonna use this. I'm gonna use the y-intercept and the slope to help me draw my first line. All right, y-intercept is 0, comma, -4. 1, 2, 3, 4. That'll be right here. Use red points. All right, my slope tells me to go down 1 to the right 3. Down 1 to the right 3. 1, 2, 3. So I'm gonna give myself a couple more points. Down 1 to the right 3. 1, 2, 3. All right, I'm gonna backtrack a little bit before my y-intercept. To go backwards, I will be up 1 to the left 3. 2, 3. All right, one more. Up right, up 1 to the left 3. 1, 2, 3. So I backtrack a couple points from my y-intercept. Even though my slope says down 1 to the right 3, I can keep on going, but I do want to see some points. So I'm not gonna connect them with the line yet. What I'm gonna do is figure out number 2, and then I'm gonna use a slope and y-intercept and get more points, so I can kind of see where they're intersecting at. Okay, because I'm looking for the point of intersection. So for your second line, all right, 5x plus 4y equal to -28. Positive 4y is positive. Variable term is positive. Let it stay. Move the 5x over. So that should be -5x on the right minus 28. Divide every term by 4. My insert -5/4. X minus 7. So my slope, -5/4. Y-intercept, 0, comma, -7. All right, so 0, comma, -7. So 5, 6, 7, that'll be right here. So as you can see, if I go down 5, 1, 2, 3, 4, 5. If I go down 5 to the right 4, I'm already outside of my grid. So that's the reason why we learn how to backtrack, because if I can backtrack, I can actually see where they're going to intersecting at. So if I backtrack my slope, that means up 5. 1, 2, 3, 4, 5. To the left 4. 1, 2, 3, 4. That'll be right here. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4. Backtrack one more time. 1, 2, 3, 4, 5. 1, 2, 3, 4. So it'll be right here. So I guess these 2 points, these 2 lines were actually intersecting outside. Since I changed my numbers, I kind of throw it off a little bit. And I do apologize. I didn't mean to have a -10 there. So right now, so when we backtrack the slope, we should be able to see where they're intersecting at. Up 1 to the left 3. So this is not going to work out for us. So let me change the numbers again. So perhaps I'm not gonna change the I'm not gonna change the red ones. Perhaps -28 might be too big. If I would change this to maybe like a -4, hopefully that'll work out. That'll be -1. All right. So it's 0, -1. Maybe it'll work out. Maybe it won't. All right. Let's give it a try. Down 5. 1, 2, 3, 4, 5. To the right 4. 1, 2, 3, 4. No, I'm gonna still miss it. One. Yeah, I will still end up missing it. So maybe I can just try another example right here. But the idea here is keep on plotting your points, and eventually you can see where they're intersecting at. So maybe this one will work. So I can't state a solution. I know what the answer is, but I cannot see on the graph. All right, see if this one work out better. I apologize. That one didn't quite work out the way we wanted. All right. My variable terms, first equation is positive, so I'm gonna let it stay. 4y equals, move the x over, negative x minus 8. Divide every term by 4. So negative x over 4 means negative 1 over 4x minus 2. All right, slope is negative 1/4. Y-intercept, 0, negative 2. I'm gonna go ahead. 0, negative 2 is right here. All right, down 1 to the right 4. 1, 2, 3, 4. Down 1 to the right 4. 1, 2, 3, 4. Backtrack from the, if you backtrack from the y-intercept. Up 1 to the left 4. That would be right here. Up 1 to the left 4. 1, 2, 3, 4. Maybe right here. All right, second equation, variable term, positive 2y is positive. Let it stay. Move the 3x over. Divide every term by 2. So my answer, negative 3 over 2x plus 3. All right. So y-intercept, my slope is negative 3 over 2. My y-intercept, 0, 3. All right, 1, 2, 3, 3 is right here. Down 3, 1 to the right 2, 1, 2. Down 3, 1, 2, 3 to the right 2, 1, 2 right there. So that point right there is a point intersection. So so the first question I show you, it was meant to do that, but it didn't quite work out. So now I'm going to connect all these points with a line. My second equation and my first equation. Sorry, it's not quite straight. All right, so what is this point of intersection right here? What is that point intersection? So that will be my answer. So this point is 4, negative 3. So the point intersection. So the solution to the entire system got to be 4 comma negative 3. So we write the answer as an order pair. So once again, I do apologize right here. It didn't quite work out with my points. So, but idea is once you plot these points, okay, go forward with the slope or backtrack with the slope. Eventually, you're gonna see you can actually follow your slope and see where the two lines are gonna intersect. All right. So this is another example. All right, both variable terms are positive. I'm gonna let it stay. If the variable terms are negative, you can actually move it over to the other side to make it positive. So right now my 3y is positive. I'm gonna let it stay. Well, I move my 3x over, that become positive 3x. Divide every term by 3, that will be x minus 3. So the slope is 1, right? My y-intercept, 0 comma negative 9. All right. So 0 comma negative 9 is way down here. My slope, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Just give myself a few points. Second one, 4y is positive, let it stay. Move the negative x over, so that become positive 4x minus 12. Divide every term by 4, my answer. Y is equals x minus 3. What do you see here? Exactly the same. Oh, I'm sorry. I don't know why I say 9. It's negative 3. Exactly the same line. Same line means the slopes are the same, y-intercept are the same. Parallel lines means the slopes are the same, but the y-intercepts are different. So these two lines are exactly the same. This will be 0, negative 3. Up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So I will end up plotting exactly the same point. So you can just, so technically, these two lines are these two lines are exactly the same line. So if it's the same line, what's my solution? infinite number solution. Okay. All right. Another way is called substitution method. Another way of solving system of equation is by substitution method. The substitution method is best when you see one of the four variables has a coefficient 1. Okay, so right now, this for this example, right, x plus 3y. So this is going back to that same problem as I had earlier. Here we're gonna find the answer here. All right, so this variable is 1, so I can use substitution methods. As long as one of the four coefficients is 1, you can use substitution methods. So solve for x, right? If that coefficient is 1, that's what you solve for. Solve for x in the first equation and call that equation first equation prime. So I'm not solving for y. I'm not doing it by graphing. All right. I'm not doing it by graphing. I don't need to solve for y. Right now I'm using substitution method. So whoever has a coefficient 1, that's the variable I'm solving for. So I'm going to move my 3y over. So my x is equal to negative 3y minus 10. I'm going to call that first equation prime, because this is going to be the equation I will come back to actually find x. So the way we are doing this is actually substitute. We are going to substitute this first equation prime into the second equation. So substitute first equation prime into the second equation and solve for y. So so this is x equals to negative 3y minus 10. So I will take this first equation prime and substitute into the second equation wherever I see an x. So once I do that, then the equation I'm about to solve will only contain the variable y. So substitute my first equation prime back into the second equation, substitute for x. So normally the second equation says 5 times x. Now you will say 5 times negative 3y minus 10. Still plus 4y. Still equal to negative 28. Now I'm going to solve for y. I'm going to give myself a little more space here. All right, to solve for y, we will distribute. So that gave me negative 15y minus 50 plus 4y equal to negative 28. All right, negative 15y plus 4y, combine like terms, negative 11y minus 50 equal to negative 28. All right, I'm gonna move my negative 11y to the right side and bring the 28 to the left side. All right, so the left side should be negative 50 minus 28, which is negative 78, equal to 11y. So divide both sides by 11. My answer, y is equal to negative 78 over 11. So yeah, there's no way I could graph this and find the answer because my answer comes involved with fractions. So now we found y. Then I'm gonna substitute y back into the first equation prime to solve for x. So remember my first equation prime says negative x equals to negative 3 times y minus 10. Now we will say negative 3 times negative 78 over 11 minus 10. And you can put this in the calculator. It will tell you the answers. All right, negative 3 times negative 78 over 11. Make sure the negative 78 over 11 is in the parentheses, minus 10. And you should get 124 over 11. All right, so the solution to this system got to be 124 over 11, comma, negative 78 over 11. There you go. right, let's try another one. I'm gonna say this is first equation, this is second equation. All right, solve for x in the first equation. So basically the whole idea is solving one variable at a time. Okay, I solved for x earlier, called that first equation prime. Then whatever I solve for, I substitute into the second equation. All right, so that means I'm solving one variable at a time. Once I figure out what my y is, substitute back into that first equation prime to find my x. So when it comes to solving system with linear equation, we can only solve one variable at a time. So the technique here is called the substitution method. I substitute one equation into the other one to solve for my variable. So this example, this x has coefficient 1. So that's the equation that's the variable I'm gonna solve for. So I move my y over, positive 4y over. So now this should be negative 4y minus 8. Call this first equation prime. All right. Oops. I'm gonna come back up a little bit. Move this all the way down. All right, now I'm going to substitute the first equation prime into the second equation and solve for y. So this is x equal, right? So I'm going to substitute back into the second equation into x. Wherever I see an x, that's where I substitute that. So the second equation normally says 3 times x. Now you will say 3 times negative 4y minus 8. Still plus 2y, still equal to 6. All right, so here I'm going to distribute. So that's negative 12y minus 24 plus 2y equal to 6. Combined like term, that should be negative 10y minus 24 equal to 6. So I'm going to move my negative 10y over, move my 6 back to the left side. So I should get negative 24 minus 6 equal to positive 10y. You know what I'm saying? So this is negative 30 equal to 10y. Divide both sides by 10, y is equal to negative 3. So once I got my y, I will substitute this answer back into the first equation prime to actually solve for x. So the first equation prime says x equal to negative 4y minus 8, right? Now I'm going to substitute my answer, negative 3 for y, into that equation. I get negative 4 times negative 3 minus 8. All right, substitute back into the first equation prime and find x. So that should be positive 12 minus 8. X should be 4. So just like earlier when I graphed the solution to the system, x is 4, y is negative 3. Okay. Now another method is called elimination method. All right. Elimination method is used when none of the 4 coefficients is 1. All right. So then we got to use elimination methods. So how do you eliminate? Okay. When terms have opposite signs, to eliminate them, to cancel them out, we have to add. If they have the same sign, we're going to subtract. Okay, so I'm going to show you how to do this. All right, so I'm not dividing up this into steps because this varies a lot. So consider following system linear equation, right? So this is my first equation, this is my second equation. I want to use elimination method. So what that means is I need to eliminate one of the 2 variables. So the question is, do I eliminate the x first or y first? Well, that depends on the coefficients. What if it's easier? All right, I think eliminating y is easier because this 3 and 2 are smaller number. So in order to eliminate y, you need to make the coefficient the same. You need to make the coefficient of the y the same. So what you do is find the common multiple between the 3 and the 2. Common multiple between 3 and 2 is 6. So I can make both of these into a 6. So if I want to make 3 into a 6, I need to times by 2. So that means the first entire equation will times by 2. All right, second equation to make that coefficient from the y into a 6. That common multiple between 3 and 2 is 6. I need to make the coefficient the same in order to eliminate the y. So to make this 2y into a 6y, I need to multiply the 2 by 3. So that means the entire second equation need to multiply by 3. All right, so the first equation, every term by times by 2, that gave me ax, positive 6y, equal to 18. Second equation, 15x minus 6y equal to 24. So in order to eliminate one variable, we need to make sure the coefficient of the variable is the same. So we need to find a common multiple of those coefficients, and then we have to multiply the entire equation. We got to make the equation twice as large or 3 times as large. All right, so what do I mean by opposite sign? What do I mean by opposite sign we add, same sign we subtract, which is right here. So in order to eliminate this, the 6y, since both term has different sign, has opposite sign, the way to eliminate them is by adding them. 6 plus negative 6 will automatically cancel out. All right, combine like terms. 8 plus 15, that's 23x, equals 18 plus 24 is 42. 18 plus 24, make sure 18 plus 24 is 18. Oops, 42. Yep. Divide both sides by 23. My answer would simply be 42 over 23. All right, so now I found one variable. Now I can substitute this answer back into any one of these 4 equations. Well, I'm not going to go back to, I'm not going to substitute this number back into the bigger equation, right? This ax plus 6y equals 18 was twice as large as the original one. The second one is 3 times as large as the original second one. So I'm going to substitute this answer back into the original first and second. So I'm going to go back to the first one. It doesn't really matter first or second, just whatever, which one looks easier to you. All right, I'm going to put this, substitute back into the first equation. So normally it says 4x, right? Now you'll say 4 times 42 over 23 plus 3y equal to 9. So I'm going to put this in the calculator first and see what that fraction is. So that should give me 168 over 23 plus 3y equal to 9. All right, this is positive, so I'm going to move this fraction term over. So that should be 3y equal to 9 minus 168 over 23. All right, figure out what that is, and we'll divide it by 3 next. So 9 minus 168 over 23. Make sure that fraction is put in the parenthesis. And you should get 39 over 23. And then divide both sides by 3. And you should get 13 over 23. All right, so this equation, the solution got to be 42 over 23, comma, 13 over 23. All right, let's try another one. All right, this one is written a little bit tricky, okay? So I'm gonna write them out. I'm gonna move the 2y over, kind of line them up correctly. So 3x minus 2y equal to 27. That should be my first equation. All right, this is a crazy looking equation. I know this x has coefficient. I know this x has coefficient 1, but I don't want to use substitution method because I'm trying to avoid having fractions when I do substitution. Okay, that's the reason why substitution method you always solve for the variable that has coefficient 1, because in that case you are avoiding end up substituting fractions, which is harder to deal with, as you can see. All right, so since my second equation has a fraction in it, I want to clear this fraction. So to clear this fraction, I need to multiply every term by 2 first, because the 2 times the negative 7 over 2y should give me a whole number, because the top 2 bottom 2 cancels out. All right, so my second equation now should become negative, excuse me, 2x minus 7y, top 2 bottom 2 cancels out, equal to negative 50. There you go. So let's write this on the side again, okay? First equation, 3x minus 2y equal to 27. That's the first equation, realigned. Second equation now is negative 2x minus 7y equal to negative 50. So now I'm forced to use the elimination methods. So I think eliminating x is easier, right? Because I can make 3 and 2 into a 6 rather than making 2 and 7 into a 14. Because the common multiple is 14 here. This common multiple here is 6. Because I definitely don't want to do 14, because then I have to multiply bigger numbers on the back end on the 27 negative 50. So I want to make both of these into 6x. So that means the first equation got to times every term by 2. Second equation, multiply every term by 3. And this is why I hate elimination method, because I had to make my numbers bigger. Okay, but here we have no choice. So the first equation now becomes 6x minus 4y equal to 54. Second equation becomes 6x minus 21y equal to negative 150. All right, now I can eliminate x. Since x has the same sign, to eliminate it, we will subtract, because 6 minus 6 cancels out. All right, be very careful here. You got to say negative 4 subtracts negative 21. If you say negative 4 subtracts negative 21, then you should get 17y. All right, here you got to say 54 minus negative 150. 54 minus negative 150 should give you positive 204. Divide both sides by 17. Your y should be 12. All right. So once I got my y, I can substitute this y into any one of these equations I worked out, or the original ones. So if you want to just go back to the original ones, like this one look kind of easy, right? You can go back to it. So I'm going to sub y equal to 12 into my original first equation. Okay. Whatever which one looks easier, that's the one you go back to. So it says 3x equal to 27 normally plus 2 times y. So now my y is 12. So this is 27 plus 24. 27 plus 24. 2 times 12 is 24. That's 51. Divide both sides by 3. 51 divided by 3. My answer, x equal to 17. All right, so the solution to this solution to this system got to be 17 comma 12, because only x equal to 17, y equal to 12 will actually be what? Will actually make both sides equal to each other. All righty. So I kind of wrote this out for you. All right, a system of linear equation is a set of two or more linear equation, right? That was on the handouts earlier. If an ordered pair is a solution to the system, we say this ordered pair is actually the point of intersection of the two lines. Okay, that's what we mentioned earlier. All right, what are the three types? Oh, that's all you gotta put. One solution, no solution, infinite number solution. You don't have to mention the consistency or inconsistent. All right, when two lines, when two lines in the system of linear equation have the same slope, which one of the following is the solution? Same slope means parallel line. Parallel lines, no solution. When solving system of linear equations, substitution method is used when you see what? When you see, let's go back up. When you see a variable has coefficient 1. All right. When solving system linear equation, use elimination to eliminate the variable if terms have the same sign, we will what? Same sign, we will subtract to eliminate. Different sign, we will add. All right. So here, this one is doing about graphing. Okay. Number 3 is actually on the handwritten portion. So on the handwritten portion, you will do the graph. Okay. But in the computer, you will actually solve for y and tell me what the slope and the y-intercepts are. Okay. Same thing for 1 and 2. Solve for y in the second equation and tell me what the slope and the y-intercepts are. So do the first two in the computer portion, and number 3 is going to be on the handwritten portion. All right, number 4, make sure you state the solution as an ordered pair. So let's see if I can find the handwritten portion real quick. All right, so number 3 is right here. Plot your points using slope and y-intercept, and then so you can draw the two lines and plot them so you can see where the point intersection is. Now go back to, so this number 4 need to be entered back on the computer. Number 4 says state the solution as an ordered pair. All right, question A is on the handwritten portion. Okay, follow these, do the same thing as I did earlier. All right, number 9, to eliminate the variable y first, find the least common multiple between 3 and 2. So I want you to eliminate y. So I want you to find the common multiple between 3 and 2, which is 6, right? To make the variable y the same, multiply the first equation by 2, second equation by 3, and you can write it down the answer right here. All right, from the answer you get for number 2, you eliminate the variable y and solve for x. So that will be right here. Once I eliminate, I need to solve for y. Okay, whatever variable you solve for, once you eliminate the variable, okay, then you can solve for that one variable. So that will be like this. Show the work like you're doing here. All right. All right, substitute the answer for x once you solve for x back into the first or second equation to find y. So it doesn't really matter which one you go back to, just find one that's easier. All right, number 10, multiply the second equation by the LCD, which is 3. So you multiply every term by 3. All right, then I want you to eliminate the variable x. Okay, find the least common multiple between 3 and 4. So the least common multiple between 3 and 4, that should be 12, right? So to make the variable the same, multiply the first equation by 4, multiply the second equation by 3. So this example, I want you to eliminate x, just like what I showed you earlier. All right, from the answer you get in number 3, eliminate variable x so you can solve for y. So I kind of guide you step by step on how to find each variable. Once you solve for y, substitute the answer for y back into the first or second equation. So I would suggest go back to the first equation. Looks a little bit easier to find your variable x. Okay, so just real quick, showing you how to find solve the system of equations by graphing, elimination, and substitution. Thank you for watching.